In this section, we're going to start talking about the math involved with the solutions by dealing with the concentration of the solutions. So we're essentially trying to figure out how much of each part of the solute and the solvent is inside of the solution. Generically, it's always going to be the solute over the solution. So when we're talking about the solution, we're talking about both the solute and the solvent added together. Whereas at the top, we only care about the solute itself, the stuff that's being dissolved. There's several different ways to express that. We could do mass per mass, so how many grams of the solute in the total amount, how many milliliters in the total amount. We can combine the two and say for every so many grams we have this much volume, this many milliliters, and then this is mainly used for chemists, and that's the molarity. You may have seen this in lab before. So this process is essentially the same for all the mass percents. So when we talk about these three, the mass percent, volume percent, and mass per volume percent, they're all going to be the same exact method. So mass percent, that should be a giveaway that we're talking about grams. So it's the grams of solute over the 2 grams added together times 100. The 100 makes it a percentage. Now, if you're given a situation where it says something like 15% solution, it's easiest, since this is out of 100%, it's easiest to say that's 100 grams of solution. Because that way we can say for every 15 grams of the solute we have 100 grams of the solution. Or for every 100 grams of the solution, we have 15 grams of the solute. It just makes it for an easier conversion. In all reality, you could have any amount you want on the bottom, but it's going to add some more work to your process if you do that. So let's take a closer look here. We have 8 grams of potassium chloride. We are adding water. I guess it says it right there. We're adding water until it reaches 50 grams. That means we have 8 grams of KCl and we have 42 grams of water, because we've had to add that 42 grams to make it 50. So we have 8 grams of KCl, 42 grams, and that gives us 50 total. It's this total amount that we are most concerned about. So here's our 8 grams of KCl. That's the solute, that's the smaller of the two, and it's going to go over the total. Times 100 to make it a percentage. So let's take a look at how much we're able to do this. A solution is prepared by mixing 15 grams of sodium carbonate and 235 grams of water. What is the mass percent? So the top number is going to be the solute. So if we have to pick between these two numbers, which one's the solute, you're going to pick the smaller of the two. So the 15 grams is going to be on top. On the bottom, you're going to have the total. So it's going to be 15 plus the 235. And that comes out to be 250. So 15 divided by 250 times 100. That comes out to be 6%, which is C. They try to trick you a bit by putting 6.38, seeing if you'll forget to do that. You want to add that in. You want to add that 15 in. That's going to be the total. Alright, so if we're looking at the volume percent, essentially it's the exact same thing, but before it said M over M, and now it says V over V. That's because this was in grams, and mass is a unit of grams. Now we're in volume, which means we're dealing with milliliters. So we're looking for the milliliters of solute, milliliters of solution. Once again, that's going to be the total. And then you're going to multiply it by 100. Also, once again, the bottom is going to be out of 100. Just to make your life easier. That's the only reason why we do that. And the mass per volume. Mass is in grams. Volume is in milliliters. So therefore, it's going to be grams of solute, milliliters of solution. And once again, we have 100 on the bottom if you're given the percent, just to make your life easier. And remember, this is the total volume. So let's take a look at this. Write 2 conversion factors for each solution. Really, you're only going to need to write 1 conversion factor. You're just going to need to know how to use it. So, we're looking for mass per mass. Mass should automatically make you think grams. So, it's going to be 8.5 grams of NaOH for every 100 grams of solution. Or we could write it the other way around. For every 100 grams of solution, we're going to have 8.5 grams of NaOH. That's what they mean by having 2 conversion factors. Volume is in milliliters. So both of these are going to be in milliliters. So that means 5.75 milliliters of ethanol for every 100 milliliters of solution. We can write those as the 2 conversion factors just by making them into fractions. So 5.75 milliliters and then flip-flopping them to make the other one. And then finally we have grams and milliliters in the same one. That's saying for every 4.8 grams of HCl, we are going to be needing 100 milliliters of solution. Notice 100 is always on the bottom, or on the other side. There we go. Now molarity. Molarity is a little bit more difficult because now we're starting to talk about molar mass, and this is more where we're using the periodic table, and chemists use this quite a bit. This is probably the majority of concentration calculations that the chemists do. So the actual definition is moles per liter. So if we have 1 mole of sodium chloride in 1 liter, 1 divided by 1 is 1. In this particular situation, they have, this is called a volumetric flask. It's extremely accurate. You see this line here? That's telling the scientists how much water to put in. So that way it's the perfect molarity. They put a mole of sodium chloride, and you can figure out how much to put it in by getting the molar mass. And that'll tell you how many grams to put in here. And then you're going to fill it up with water and mix it. Fill it up to that mark and mix it. And you will have a perfect 1 molar solution. So let's take a closer look at this particular example. If we look at the periodic table, we're looking at NaOH. Here's Na. I'm sorry, we're looking at NaCl. And here's Cl. We have 23.0 grams for the sodium, and the chlorine is 35.5. So that comes out to be 58.5 grams per mole, which means if we want 1 mole of the NaCl, we need to weigh out 58.5 grams. And then you just add enough water, 1 liter of water, till you get to that mark and mix it up. Alright, so let's take a look at doing an actual equation. What is the molarity of 0.225 liters of potassium nitrate solution with 34.8 grams of potassium nitrate? There's a couple different steps here. First, we know that molarity is equal to moles over liters. While we have the liters here, what we need is the moles. While we have the grams, we can get to moles. Once again, as soon as you see grams, I'm thinking molar mass. So I need to figure out the molar mass of KNO3. So I have K, N, and O. 1 potassium, 1 nitrogen, 3 oxygen. So I'm looking at the periodic table. Potassium is right here, 39.1. Nitrogen is right here, 14.0. And oxygen is right here. Kind of hard to see, but it's 16.0. So that's 39.1, 14.0, and 3 times 16 is 48. We're going to add those together. And it comes out to be 101.1. We know that we start off with 34.8, so we're going to do 34.8 grams over 1. In the next bracket, we have grams on the top. That means I want to put grams on the bottom of the next one. 101.1 goes with grams. And 1 mole goes on the top. Whenever you have molar mass, 1 mole goes on top. So 34.8 divided by 101.1. That comes out to be 0.344 moles. They tried to trick you saying like, oh, you're done here, but you're not. You have to figure out what it is, what the molarity is. So molarity is 0.344 moles divided by the total volume, which is 2.225 liters. Which comes out to be 1.53, which is actually B. So just as a summary, we have different units of molarity, or of concentrations. We have mass to mass, so that means when we have 10%, it's 10 grams for every 100 grams. We have volume to volume. That means for every percent is 12 milliliters to 100 milliliters. Mass is in grams, volume is in milliliters. If we have both, the M is grams and the V is milliliters. So that means for every 5 grams, we have 100 milliliters. And then for the molarity, molarity is always moles per liter. What I would do every time I see a big M, I automatically change it to those units so I know what units I'm looking for. It sometimes makes your life easier when you do that. So let's take a look at a practice problem. How many grams of sodium hydroxide are needed to prepare 75 grams of 14% mass by mass of sodium hydroxide solution? So if we're looking at this, we can put this into a conversion factor saying for every 14.0 grams of NaOH, there is 100 grams of solution. We're looking for the grams of NaOH, so we're looking for grams of solute. they're giving us the grams of solution. So we're starting off with 75.0 grams of solution. That's how much we actually want to make. For every 100 grams, because solution's on the top, we want to put grams of solution on the bottom of the next one. 100 goes with grams of solution. And 14.0 grams of NaOH, then we go on the top. And notice, grams of NaOH is what we're looking for. Grams of NaOH is on the top of the last bracket. So it's going to be 75 times 14 divided by 100. Which comes out to be 10.5. How many milliliters? Notice it's in milliliters now, and we have volume to volume. 5.75% ethanol solution can be prepared with 2.25 milliliters of ethanol. So this is the ethanol, so that means that's the solute. This time we're given the solute. We want to know how much total can be made. So we're looking for total volume. So once again, this can be turned into a conversion factor. For every 5.75 milliliters of ethanol, we will produce 100 milliliters of solution. So we're starting off with 2.25 milliliters of ethanol. Because we have milliliters of ethanol on the top, that's what I want to put on the bottom of the next one. 5.75 goes with the milliliters of ethanol, so that's going to go on the bottom as well. That equals 100 milliliters of solution, which is what we're looking for. We're looking for the volume of the solution we can make. So it's going to be 2.25 times 100 divided by 5.75. That comes out to be 39.1 milliliters of the solution, which is then C. And now we're actually getting to one of the hardest questions you're going to do, and that's when we're dealing with molarity. Once again, as soon as you see the big M stands for molarity, which is moles per liter. So that means we're given 0.15 molar solution. We want to make 125 milliliters. We want to know how much of AlCl3 we need. First thing that you should realize is giving you milliliters, except molarity is in liters. That's a problem. You have to get the milliliters to liters in order to use this. So 125 milliliters for every 1,000 milliliters, there's 1 liter. So we're going to end up dividing by 1,000 here. Now we can plug it into the molarity equation. Molarity is equal to moles over liters. Well, now at this point it's just plug and chug. We're going to cross multiply in order to solve for the x. So 0.15 times 0.125. So x is then equal to 0.01875 moles. We want grams. The moment you hear grams, once again, you think molar mass. That means I need to figure out the molar mass of AlCl3. So we have Al, we have Cl. We have 1 Al, we have 3 Cls. When looking at the periodic table, aluminum is right here, 26.98. That means it's 27.0 if we round it up. And then chlorine is right here, 35.45 rounded up. 35.5. So 3 times 35.5 comes out to be 106.5. We're going to add those together. And that'll give us grams per mole. That's our molar mass. So we know how many moles we have, and we know the molar mass. That means we can convert. So 0.01875 moles all over 1. Moles on top, that means we want moles on the bottom. Whenever we're talking about molar mass, once again, 1 always goes with moles. And then 133, the molar mass itself, goes on the other side of the line, of the division line. So 0.01875 times 133.5. 2.50 grams. That was a rather long question, so I hope you were able to follow that one. And that's the end of the concentration section.